Hello everyone. This lecture series is brought to you as a courtesy of Raj Malhotra's IAS Institute, Chandigarh. It's been 2 years since Chandrayaan 2 has been orbiting the moon's surface. So, with this regards, ISRO had organized certain workshops in which it has showcased the different information gathered by the 8 payloads that Chandrayaan 2 orbiter was carrying. So, 8 payloads are basically scientific equipments which were there to analyze the moon's surface on a global scale. So, Indian Express's today's explained section covers this very topic, and which is why it is the topic for our today's discussion. So, let us start with the lecture. So, these are basically the 8 payloads which was being carried by Chandrayaan 2. One by one we will see as to what sort of information has been gathered by these 8 payloads. So, let us start with the first one, which is the terrain mapping camera 2. Why it is called as 2? Because Chandrayaan 1 was also carrying such camera, and this was an improved version of this very camera. This camera, through its imaging, global scale imaging of moon, has brought out certain interesting geologic signatures of lunar crustal shortening and identifying volcanic domes. So, lunar crustal shortening का मतलब क्या है? Basically, as we know that there is divergence and convergence in crusts, and which is why the crust gets damaged and it gets shortened. So basically, it has actually observed signatures of divergence and convergence in moon's crust. Secondly, it has identified volcanic domes. So as you see, as you know, that if supposedly this is the surface of the moon, and over here the volcanic magma comes up. So what will happen? This volcanic magma will deflect to both the directions, and this entire region is known as volcanic crust. So it has also mapped these very areas on the moon. Then we have the Chandrayaan 2 large area soft X-ray spectrometer, also known as CLASS. So this spectrometer was there so as to monitor different minerals on the sun. So what has this spectrometer found and how does it work? So basically, this spectrometer sends X-rays into moon's surface. So what happens is, if there are any metals present over here, every metal has different absorption capacity and different reflection capacity. So what happens that at the rate at which a metal is going to absorb and reflect the X-ray is fixed. So which is why by these reflections we get to know as to what sort of mineral is present beneath the moon's surface. So it has brought us signatures of chromium and manganese for the first time, that these two minor metals are present on moon's surface. Apart from that, from earlier experiments there was ambiguity with respect to whether sodium was present on moon's surface or not. This experiment has also clarified this thing and has confirmed the presence of sodium also on lunar surface. Then we have the solar X-ray monitor. This has analyzed the solar flares received by moon from sun, and it has generated sufficient data or good amount of data in order to study the coronal heating problem of the sun. Now what is coronal heating problem of the sun? Let us also understand this thing. So basically, like Earth, sun also has different layers. For example, this is the sun and this is the core of the sun, where nuclear fission reaction is happening, and this generates basically heat. So the area of sun that we are able to see is known as photosphere. Then there is chromosphere, and then there is corona. So basically, although photosphere is seen to us, visible to us all the time. However, chromosphere and corona is only visible during the time of solar eclipse. Now, what is the problem with respect to heating of corona? So, as general science would tell us that if heat is being emitted from this very region, so the area that is the layer of the sun that is most near to it would be the hottest one. However, over here the corona happens to be the most hottest area of the sun and not the photosphere. So this is an anomaly, and this very solar X-ray monitor, it is a monitor, it has to observe. So has actually generated certain data which is going to help us in future in order to understand this very problem. Then we have the orbiter high resolution camera. As the name itself suggests that this camera is in the orbit and it is going to look at the moon's surface. So what has been the achievement of this very camera? So this very camera has been able to get extremely high resolution images about 25 centimeter apart. So for example, this is the moon, this is the orbit that is 100 kilometers apart from the moon. Over here, from this very payload, this camera can see on moon's surface two objects which are about 25 centimeter apart. So it can actually identify two objects if there are 25 centimeter apart. If they are closer than 25 centimeter, then it will count that object or show that object as one. So this sort of resolution has been for the first time that images of such high quality resolution has been generated. Then we have the imaging infrared spectrometer. Now what has this spectrometer done? Basically, again, the job of this spectrometer was to find the presence of water, and it has actually found it with most distinction. Why do I say with most distinction? Although Chandrayaan 1 and various other missions had also detected the presence of water molecules on lunar surface. However, what was the problem at that point in time? Basically, the imaging that was done, the spectrometer imaging that was done by earlier probes could not differentiate between hydroxyl and water ice. So water ice is H2O, hydroxyl is OH, this also has a component of OH. So what if we are misreading both of them as one only? Then this spectrometer has helped to differentiate between both of them, H2O and OH, and has found presence of both hydroxyl and water ice at different places on the lunar surface. So this is giving us conclusive proof of presence of H2O, that is water, on the lunar surface. Then we have the dual energy synthetic aperture radar. So what has this radar helped us? Basically, this radar has studied the polar areas of the lunar surface, and it has been able to provide distinction between roughness on the moon's surface, polar areas, and presence of water ice. So basically, earlier when we were looking from above, we could not distinguish whether this area was just rough patch of the moon or this area had ice. So with the help of this very radar, this high quality radar, now we can find distinction between both, and it has also found presence of polar ice on lunar surface. Water ice, sorry. So then we have the Chandrayaan 2 atmospheric compositional explorer 2, which is also known as CHANS 2. So as the name itself suggests, it is going to explore the atmosphere of the lunar surface. So what has this been able to found? Basically, just like the Earth's surface, the lunar core also has the radioactive material that is known as K40 potassium 40. So what happens is, when this potassium 40 disintegrates, it releases the gas argon 40 in the exosphere of the lunar surface. So, the difference in the concentration of argon 40 will tell us with respect to how much radioactive activity has been going inside the lunar core, and therefore it has tracked down the variability of concentration of argon 40 at different latitudes of the exosphere of the lunar surface. Then we have the dual frequency radio science experiment. So, again this experiment is basically studying the ionosphere of the moon and how solar photoionization has been affecting it. So, this was basically all the 8 payloads and what all these 8 payloads has brought to us in form of their information. Now, how is this going to help us? So, basically what all do we have? Now we have information with respect to mineralogical and volatile mapping of lunar surface. We have surface and subsurface properties of the moon, and we have started quantifying water in various spaces across the lunar surface, as in where it is at the polar surface and where it is at the shadow area of the moon. Then maps of element present on the moon. The spectrometer has told us as to where magnesium is present, manganese is present, where sodium is present. Now, how it is going to help us in future? So, in future this is going to help us in the manner that now we will be knowing as to where craters are present, where boulders are present while landing, and apart from that we will also know as to where to dig, because now we know as to where minerals are present. So, what are the future missions that are going to go to the lunar surface and which can seek help with the findings of this very Chandrayaan 2 orbiter's finding? So, these are, one is a collaboration between Japanese Aerospace Exploration Agency and ISRO, which is the Lunar Polar Exploration. It is set for 2023-2024. Then we have NASA's Artemis, which is a mission for human landing, and then there is Chinese lunar mission. So, had the orbiter was along with the orbiter, the rover and the lander been also over there, then the rover and lander could have provided us with much local information. With respect to the orbiter, we have got the global information with respect to lunar surface. So, this is all with respect to today's lecture, and we have expressly understood as to what all are the takeaways from Chandrayaan 2. Should there be a match the following question, we should be able to tell as to which sort of payload has provided us with which information. I am also attaching the PDF version of this PPT along with this very lecture. Should you have any doubts with respect to this lecture, feel free to put them in the comment section. Thank you and have a nice day.